In the last decade, we saw a steady growth of package ecosystems and the adoption of package managers by developers. In those software ecosystems, client packages can enable a dependency on a provider package. A dependency allows a client package to reuse all functionalities of a provider package. From the point of view of the client package, the maintenance of the provider is performed by a third-party development team, which prevents redundant work. Package managers help client packages to keep their provider packages up to date. In our example, we can see that the client package can set a versioning statement to determine the range of versions of a provider that can be automatically updated. In this paper, we study the phenomenon of downgrades. A downgrade is a fast workaround to fix issues that appear after a dependency is updated by a client package. A downgrade cancels the effect of an update. It makes client packages to lag behind the newest features and bug fix from the latest provider version. To detect a downgrade, we look at each pair of release of a client package. We verify whether the adopted provider version in the actual client release is smaller than the adopted provider version in the previous release of the client package. If so, then a downgrade is detected. However, it's not trivial to find the correct way to sort the client package's release. If we assume that a chronological order of the release is the correct order, then we get a numerical inconsistency between the release. For example, in the sequence of release in the figure, version 1.1.2 comes after version 2.0.0. Considering a downgrade between these pair of release doesn't make much sense. Similarly, if you assume a numerical order of the release, then we get a chronologically inconsistent release ordering. For example, in the sequence of release of the figure, version 1.1.2 comes after release 2.0.0, but in reality, version 2.0.0 never existed when 1.1.2 was released. Our solution is to consider a branch-based ordering of the releases. In this ordering schema, one version can be followed by more than one release. See, for example, that version 1.1.1 is followed by both 1.2.2 and 2.0.0. We believe that our branch-based sorting schema is of interest to researchers studying other issues related to the versioning of packages in software ecosystems. For our study about downgrades, we collected data from NPM and GitHub. We also performed a manual analysis of a random sample of 371 releases that contain a downgrade. We analyzed the commits, the pull requests, and the issues that are associated with those releases. And we collect data from NPM, but why NPM? Because NPM is the largest and most popular ecosystem nowadays, and therefore it has a large impact over developers. Also, NPM implements an automatic update mechanism, which is of interest in this paper. In our first RQ, we explored the factors that drive a client package to downgrade a provider package. We identified two main drivers. First, the client package downgrades the provider to react to an issue that occurs when he previously updated the provider. The client package also downgrades the provider to prevent future and potential issues with this provider. The takeaway from this RQ is that client packages should emphasize testing functionalities that relies on the provider package. In our second RQ, we investigate how the client package changes the way they adopt the provider package during a downgrade. We observed that almost half of the client packages deactivate the automatic update mechanism. 3/4 of the deactivations regards one single provider package. showing that developers usually lose the trust in a specific provider package and not in the automate mechanism as a whole. Also, in 30% of the downgrades, the client packages end up rolling back the provider more than it should. For example, in our slides, we can see that instead of rolling back to 1.2.3, a client package can roll back to 1.2.2, even though this client package was previously using 1.2.3. We also observed that in 37% of the downgrades, the client package keeps using the automatic update mechanism, and only 13% of the downgrades are performed over a provider package that's not automatically updated. Our third RQ studies how fast downgrades are performed. We've observed that downgrades of automatic updates take significantly longer than downgrades of manual updates. This observation suggests that automatic updates are hard to trace back to the accountable provider. The implication of this RQ is that client packages should periodically log the adopted provider versions to help debugging troublesome automatic updates. To wrap it up, in this paper we devised a branch-based approach to sort client packages. We also studied why downgrades occur, and we found that two types of downgrade occur: reactive and preventive downgrades. We also study how the versioning of providers are modified in a downgrade. And we observed that 49% of the downgrades involve a deactivation of the automatic update mechanism. Finally, we study how fast those downgrades are performed. And we found that releases with a downgrade are 2.6 times faster than regular release. Thanks for watching, and you can find the full paper in the conference website. Thank you.
For this wonderful presentation. I encourage all the audience to write their questions in the chat so that I can propose these questions to Felipe. Meanwhile, I can start with my question. So my question is, you had 3 research questions, and you had some findings. And those findings are related to open source projects. Now, the question is there any context where you think that your findings do not apply? Because you selected some projects, they're open source, they're in a particular domain, and maybe if you run it on a bank system, that the findings will be completely different. So would you expect any finding to be particularly different in a specific context?
Mm-hmm. Yeah, maybe like one of my findings is that some of the downgrades are kind of induced by some dependency bots, right? So in these cases, I don't know how much the developer willing to really, downgrade those dependencies. At least it started from the developer by itself, right? They're willing to downgrade. So maybe in this case, these downgrades, I would say they might be artificially induced by a bot, right? In the sense that maybe was not the exactly what the developer wants to do, but it end up doing because the bot was suggesting that. So I think these are situations in which we could give a better look. But the thing is that I manually analyzed a sample, a representative sample, a statistical sample of the downgrade, and the number of downgrades were really induced by bots really small. So I believe if that's a threat, it's a small one.
Okay, so we have a question from Ivan, and the question is, did you observe the reasons why developers decided to downgrade instead of keeping the same version?
Thanks, Ivan, for the question. Yes, in our first RQ, we analyzed the rationale behind the downgrades, right? And as far as I remember, we never asked developers, so everything that we came up with as an explanation for the downgrade, I wouldn't call like the reason for downgrade, but definitely I could look at the situation in which the developer was facing, and then he decided to downgrade in that specific situation. So I believe this is the rationale for the downgrade. But rationale is really when you update to a new version, right? You face a bug in this new version of the provider package, and probably the developer, he doesn't want to fix that problem at that specific time. So the easiest workaround is just to go there and downgrade to the previous version that was working. But the other reason is it's not a bug exactly in the provider package, but when the upgrade occurs, the build of the client package just break, right? For many different reasons. And then again, looks like that the client developer, he doesn't want to deal with that problem at that time. So he just go back to the previous version that was working. So as far as I remember, these are the two main reasons for someone downgrading, right? He basically it's a problem, the upgrade, and then he upgrades. And the other reason is that sometimes a bot can catch this situation before the developer actually realized there was a problem with the upgrade. And in this case, the bot kind of really recommends the developer to what we call pin dependency, right? To remove the range later. So you cannot upgrade the provider package within a range anymore. You need to accept a very specific range version of the provider package. So when that happens, and the developer accepts the suggestion made by the bot, they can end up downgrading the provider package as well.
Okay, so we have a new question from Sridhar, and the question is, after downgrading, let's say from 1.2.0 to 1.1.9, and if the package has to be upgraded to a new version, like 1.2.4, there will be many challenges. I'm wondering how these kinds of cases can be handled. Thank you.
That's a very good question. Thanks for this question. I don't inspect exactly this in my paper, so everything I'm saying here, it's basically what is in my mind or some observations of research that we did after this paper. So I think that I can say it's not in the paper. We inspected this later in a follow-up paper. Actually, we are working on this, but like almost half of the downgrades are eventually undone, which means that you downgrade, right? But then later on you upgrade again to another version that I believe it's working for the client package, right? As for the challenge that people face when they are re-upgrading, I'm honestly not sure. I believe that this should be smooth because one of the things that we realized is that the downgrades are very specific to some provider packages, right? So that means that the client package developer, he doesn't go crazy and say, I will pin all my dependencies. No, he can really identify the dependency that it's causing some trouble to him, and he go there and pin that dependency or downgrade that dependency specifically. So I believe, again, I cannot support with very evidence, but again, because we see almost half of all the downgrading undone, I believe that transition, which we also believe that the provider package realized it up, introduced a break change or something like that, and then the transition to the new version without changing the problem is more smooth to the client package. But again, sorry, I everything I said here, I believe so, right? I don't have strong evidence to support this.
All right, so we need to wait your next paper, I guess. if I understand correctly. And so the next question from Suhaib is, did you look if the downgrade happens right after an update, or it usually takes some time?
Yeah, that's a great question. Thanks, Suhaib. I think we explored this in our last RQ in this paper. And yeah, we found that compared to the, like, how did we measure the time to the downgrade to happen, right? We measure the time as the between the update, so the release of the client package in which the update occurs, until the release in which the downgrade occurs, right? So we measure the time between those releases. And we need a baseline in there, right? Because, okay, it took 5 hours. What is 5 hours, right? So we compare this time between upgrade and downgrade with the median time between release of the client package, right? So compared with the median time between release of the client package, the time to upgrade takes almost 3 times more, right? Which makes us believe that somehow the client package spends some time trying to, figure out what the problem is, why he built broke, right? And this kind of thing, until he identifies, oh, this is the provider package that is causing me some trouble, so we will downgrade this guy. Again, this is also kind of triangulated with our finding that the downgrades are very specific. They usually a single provider in a release that has a downgrade, right? So the client package spends some time trying to figure out the problem and what dependency is causing the problem until he finds, and then he'll go there and downgrade, right? And release a new version.
Okay, perfect. So you just ended answering the last question on time. I remind everybody that now me and Felipe will go to a discussion room, which is related to this presentation. The other attendants who stay here will watch the next presentation, which is about assisting Android API migration using code example. Okay.
I appreciate the questions, the hosting. Thank you so much.
I think we are offline. Now, on the